So in this class we are discussing Graeco Latin square design. Graeco Latin square design. So what is its definition? Its definition is: consider a k by k Latin square and superimpose on it a second k by k Latin square. So you have two k by k Latin squares. So this is one k by k Latin square, this is another one, and we superimpose if the two Latin squares, when superimposed, have the property that each Greek letters appears once and only once in each Latin letters. The two Latin squares are said to be orthogonal, and the design obtained is called a Graeco Latin square. Let me explain with an example. So suppose k equal to 3, and we have two Latin square design. So first one is suppose A, B, C. So three treatments A, B, C, and so this is C, A, B, B, C, A. So this is a Latin square design of order 3, and the A, B, C are the treatments, and the rows 1 represent the levels of one factor. So this is one level, and this is one factor, and this is other factor. So it has the levels are represented by rows. Levels of Q are represented by rows, and levels of P's are represented by columns. So this is a general setup for a Latin square design. Here one treatment occurs only once in each row and each column. So A is occur in this row, A is also in this column. Similarly, A is occur in this row and A is occurs in this column only once. This is true for all the treatments. So this is actually Latin square design. Now we define another Latin square of same order, and the treatments are represented by the Greek letters. So alpha, beta, gamma. Okay, gamma, beta, alpha, beta, gamma, alpha. Suppose you can randomize the rows or columns. Okay. This is also a Latin square design, and Graeco Latin square says if we superimpose this on this on this. Okay, superimposing two Latin square design. So let me write the superimposed form. So this is alpha, beta, gamma, gamma, alpha. This is alpha, beta, gamma, gamma, alpha, beta, and beta, gamma, alpha. Superimposing means we write first second one, then write A, B, C, B, C, A, C, A, B. So actually this is one in the first experiment cell, this is in the second cell, and this is third cell. Okay, so this is what is called the superimposing of two Latin square designs. Okay, so this is superimposing, and this has to satisfy certain conditions to get a Graeco Latin square. So what are the conditions? So the condition is, so remember, first set of treatments are represented by A, B, C Latin letters, and second letters by Greek letters. Okay, so then we when superimposed have the property that each Greek letters appears once and only once with each Latin letter. Okay, that is the condition. So example is here. Here alpha A, suppose A and alpha. So A is one treatment, alpha is another one from first Latin square, and this is second one. So you can find any this combination in any other cell. So A alpha is only occur only once. A alpha. Okay, that is the idea. So A is here in this column, alpha is in this column. A is in this row, A is in this row only once. So that is the idea, A alpha. So again I am reading, there is a property that each Greek letter appears, suppose first one is alpha and next one is A. So each one only once. So alpha occur with A only once. The two Latin squares said to be orthogonal. So in this case the two LSDs, first LSD is ABC type and another is alpha beta type. So these are orthogonal, and the superimposed design is said to be Graeco Latin square. So that is the idea. So A alpha is B beta, C gamma, D delta, etc. So these are only occurring only once. So this combination, A alpha combination, only occurs in one. That is the idea. So this type of designs are Graeco Latin square. So remember that in Latin square design, we have two factors P and Q. So we are eliminating the sources of variation by these two factors. The effect of these factors P and Q through LSD. So in Graeco Latin square, a third one. So suppose this is alpha, beta, etc. is another factors, then third one also eliminating. So third source of variation can be eliminated. So this is an improvement over LSD. Okay, that is the idea, Graeco Latin square. So remember how to construct a Graeco Latin square. Then we are going to the analysis part. So we can represent the model as Yij KL as general effect. This is mu is actually the general effect, plus theta I is the row effect, then column effect tau j, then this is tau j is Latin treatment effects represented by Latin letters, and omega k is the treatment effect. The treatments are represented by Greek letters. Then phi r column effect is phi L is represented by column effect. So here we have two types of treatments. First represented by Latin letters, second represented by Greek letters. So the treatments are two types of treatments. Then row effect, then column effect. So add all these effects, they are fixed effects. So general one, then row, then column, then Latin letter treatment effects represented by Latin letter, and treatment effects represented by Greek letter, and finally an error term. So this is random, and all others are fixed. So we are discussing a fixed model. And actually this is represented by columns and rows. columns. So we can analyze using actually two-way classification as just as in the case of Latin square design. So so the analysis of variance is very similar to that of a Latin square design. So in Latin square design we use classified data as data from a two-way classification. Because the Greek letters appears exactly once in each row, because the Greek letters appears exactly once in each row and each column, exactly once in with each Latin letter, the factor represented by Greek letters is orthogonal to rows, columns and Latin letters treatment. Therefore, a sum of square due to Greek letters. So, in addition to Latin letter treatments, we have a Greek letter treatments, and this may be computed from the Greek letter totals. So, you have to find row total as in the case of Latin square, column total as in the case of Latin square, and treatment totals. So, treatment totals, so consider A, then the value of A in this cell, observation, and in this cell, then A here, A here, A here. So, treatment totals of A, and similarly you have to find treatment totals of B, C, etc. Similarly, you have to find the Greek letters treatment totals. Treatment totals corresponding to alpha, corresponding to beta, corresponding to gamma. Okay. So the total variation treatment totals divided into Greek letter treatments total plus Latin letter totals. So therefore a sum of square due to Greek letter. So this is the new factor, new set of treatments alpha beta Greek letter treatments. This may be computed from the Greek letter totals, and the experimental error is further reduced by this amount. So error is variation, some variation is due to by these Greek letters. So the correspondingly this error amount is reducing. Okay, so the analysis of table is displayed here. So we have source of variation. First one by two types of treatments. First by Latin letter treatments and by Greek letter treatments. Earlier in LSD only treatments. So now we have treatments, first type of treatment and second treatment, second set of treatments. Then rows, columns and error. Okay. And sum of squares are similar to LSD. So rows are so k rows, k minus 1 degrees of freedom. Find the Ri is the row total. So summation I, then 1 by k minus correction factor g square by k square. So this is sum of square for rows and 4 columns. Write just totals rows by C columns corresponding to C, and Greek Latin letters treatments are TL totals, and TG is Greek letter totals. So find the terms are explained here. The treatment totals Latin, treatment total Greek, row total, column total, grand total, and mu is the grand mean. Okay, so you can find F mean square by dividing corresponding degrees of freedom. So this is enough. You can just stop at this point, and you can compare the mean square error by corresponding with corresponding treatments. So you will get F. So compare treatments. So treatments have the degrees of freedom k minus 1, and remember this degrees of freedom of error is k minus 3 into k minus 1. In LSD it was k minus 2 into k minus 1. Now in Graeco Latin square this is become k minus 3 because we have another set Latin Greek letters. So remember, and finally you can come to a conclusion by comparing the theoretical values of f corresponding to this f distribution. So in summary, we how we construct a Graeco Latin square. We have two. First construct a Latin square with Latin letters, and construct another Greek Latin square with Greek letters of same order, and superimpose it such that each Greek letter comes only once with each Latin letter only once one, or they should be orthogonal. So superimpose two orthogonal Latin square designs of same order. So in this case we are eliminating the sources of variation of another set of treatments. So three sources of variation, one by rows, by columns, and another set of treatment. So this type of letters designs are Graeco Latin square, and analysis similar to LSD. So just let me mention the LSD. So this is LSD. This is Latin square design. So when come to analysis part, remember rows. Source of variations are first rows, columns, treatment. So in Graeco Latin square we split these two, Latin treatments, Greek treatments. Each has degrees of freedom k minus 1. So first one is k minus 1, second one is k minus 1. So there are changes k minus 1 into k minus 3 in Graeco Latin square. So row totals are there, column totals are there, treatment totals are there. So all other things are same. So analysis is similar to LSD, but remember the splitting of sum of squares and the splitting of degrees of freedom. So that is Graeco Latin square. Remember, you can for randomization just randomize the columns, then randomize the rows together. You will get the LSD randomizer LS. So in randomization, for randomization we randomize the columns and rows together. Okay, so that is Graeco Latin square. And finally, this is one of the question from previous question paper. The question is, write down the model of a Graeco Latin square. Write down the model of a Graeco Latin square and also give an example plan of it. So just example plan, you can write this and just explain the definition. This is weighted 2 question. This is a weighted 2. Okay, thank you.